All right, welcome everybody. This will be an Algebra 2 lesson. There are some algebra things we need to go over before we jump into calculus. So we'll just do a quick little review. Shouldn't be too bad. So let's take a look here. If we look at these notations here, let's focus on this one. If we say 8 to the 1, we're just saying that this is just 8, right? If we say 8 to the 2, we're saying, 8 times 8, and that is 64, right? If I say 8 to the 3, we're saying 8 times 8 times 8, and that is, holy crap, what is it? 512? I have no idea. Let me check real quick. Is it 512? 8 times 8 times 8. Yes, it's 512. Okay, great. So now we just have to review these values here. If we say 8 to the 0, this is 1. Any value to the power of 0 will be 1, except 0 to the 0. You're not allowed to go with that. So yeah. But then what happens if we have negative value, like 8 to the negative 1? Here, a long time ago, when we did this, notice, or look at the progression. Notice that when we went from 8 to the 1 and 8 to the 2, from here we are multiplying by 8. And here we're multiplying 64 times 8. So then the opposite has to be true, that if we're multiplying by 8 this way, then when we're going this way, we are dividing by 8. So notice that 512 divided by 8 is 64. 64 divided by 8 is 8. What is 8 divided by 8? It's 1. So then what's going to happen here? This has to be 1 divided by 8. So notice that this is really just 1 over 8 to the 1, which is just 1 over 8. And then if I divide 8 again, this will be, if I have 8 to the negative 2, we just say this is 1 over 8 to the 2, which is 1 over 64. So that idea, when you see that negative exponent, you're just putting it 1 over. Okay. Oh crap, I hope the visual wasn't too bad. But okay. And that's the idea. So here, let's just have a little exponent rule. Some x to the 0 will equal 1 for all values of x where x does not equal 0. You're not allowed to have 0 to the 0. Okay, but any other number to raise to the power of 0 will be 1. If we have some x to the negative n, just like we had over here, like 8 to the negative 1 and 8 to the negative 2, the notation or the rule we'll have with it will be 1 over x to the n. Okay? Okay. So that's just the first little review. Let's look at the next part over here. Now, the next question we have is, which we went over last year in Algebra 2, but what if we have fractions in our exponents? So like here, if we had, let's say, we had all these values were whole numbers, right? Like positive whole numbers, 0, negative whole numbers. Negative integers. Here, what happens if we have fractions in our exponents? The notation that we're going to use is this is equal to 9, and we're going to take the square root of it. Like here, notice that this index over here is 2. What about over here? This will be the cubic root of 8. This will be the fourth root of 625. Okay? That's how we convert. That's how we work with fractional exponents, right? So hey, 9 to the 1/2 is the square root of 9, and that's just equal to 3. 8 to the 1/3 is the same as the cubic root of 8, and that would be 2, because 2 times 2 times 2 is 8. Okay. The fourth root of 625, that would be 5, because 5 times 5 times 5 times 5 times 5 is 25, 125, 125 times 5 is 625. So there it is. Okay? Okay, so exponent rule number 3, x to the 1 over n is equal to, try and finish it on your own. How would you convert this into radical form? The nth root of x. Awesome. Okay, let's continue. Here, What happens before if we had 8 to the 1 over 3, just like we just had previously? This is the cubic root of 8, and that was equal to 2. But then what happens if we have our numerator for our fraction is not 1? What if we have some sort of 2 or some sort of 3 over 4? Okay, so let's take a look here. What will this equal if we had 8 to the 2 over 3? There are two ways of expressing it. There's method 1 and method 2. So I'll show you both ways. One way you could express this 8 to the 2 over 3. Notice that first off, it's going to have that cubic root of 8, right? Because we're used to that the denominator for these fractional exponents goes on the outside of the radicand, right? So that index over here. So we know that this is cubic root of 8 and cubic root of 8. But then what do you do with that 2 over here? You could do it two ways. You could have it with the 2 on the outside here. 2 on the inside here. Or you could have 2 on the outside of the whole entire expression. So you could square the 8 first, or you could evaluate this first and then square it. Or whatever is on the numerator will just go on that outside here. So let's just make sure that it does work. Here, if I were to put the square on the inside, well then this becomes cubic root of 64. And what is the cubic root of 64? It is 4, because 4 times 4 times 4 is 64. So notice that we get 4 this way, but would we get 4 the same way if we looked at it over here? Well, let's see. What's the cubic root of 8? That's 2. And 2 squared is 4. Okay? Why don't you try it with this way over here with 625. Show it, pause the video, and show it both ways just to make sure you get the same value on both sides. Right? So here I could say, all right, the fourth root of 625, and I'm going to cube the whole thing. Or I could do cubic root of 625, and then I'm going to take the whole thing. Oh, whoa, pause. This should be a 4 here, I'm sorry. And then we're going to take the whole thing and cube it. So yeah, here notice that to take 625 and raise it to this power, that will be a lot of math. So hold on, let me actually find that number. So if I have this, if I have 625 times 625 times 625, boom. Notice we get this huge value of the fourth root of 244,140,625. Okay? And if I were to go like this, and I were to take the, notice that this notation here has the yth root of x, so here this, and I just do 4, it will give me 125. Okay? So the fourth root, what number times itself 4 times will give me 244,140,625? It is 125. Oh, sorry, 125. Or I could have done it like this. What is the fourth root of 625? It's 5, and 5 cubed is 125. So generally, I like to do it this way because squaring this or taking what's on the numerator and then raising it to that power make the number much larger. But you have to understand that both ways work. So notice that if we have some exponent rule over here, let me just move this to the side real quick. Take your time here. What do you think would be the two ways you could express any x to the m over n? How could you express it? Oh, the glare is really bad. Sorry. Okay, maybe that's a little better here. Oh, sorry. Okay, here you could have it as the nth root of x to the m, or you could have the nth root of x, the whole thing to the m. But notice that you could express it either way, like this or like this, okay? And I could tell, my bad, the light's a little bit off, but yeah. Okay, awesome. All right, one more section over here. What I'd like you to do is take each expression and convert it to radical form, and solve, if possible, for these questions below. So take a minute and copy these questions from 1 to 7, or 1 to 7. And what I'd like you to do is convert each of them into some radical form and solve if possible. So let's take a look at this one. Here, how would you express this into some radical form? Notice that just like we showed in this part here, any x to the m over n, notice that the n, the denominator, goes on the outside of the radicand. So this is just the fifth root of x squared, or you could have said the fifth root of x, the whole thing squared. Either one would have worked. Okay? But notice that this is converting this expression into some radical form. Try that for the rest of them and see what you get. Here, what would we get for this one? This would be the fifth root of 32 and the whole thing squared. You see, I would rather square whatever this is than having to square the 32. Fifth root of 32 is 2. 2 squared is 4. Because why is the fifth root of 32 2? Because 2 times 2 times 2 times 2 times 2 is 32. Okay, let's take a look at this one. This one here, notice that anytime you have some negative exponent, what was the rule that we had over here? You should always think 1 over. Notice that whatever this x to the negative n is, we're going to have 1 over the positive version of it. So then here, we're simply just first going to say 1 over x to the 2 over 5. Because anytime you have some negative exponent, we have to bring it over 1, right? And then this just becomes 1 over fifth root of x squared. Okay? That's it. Like, notice that here, these are the two same questions, but this has a negative exponent. So we just have that 1 over. Okay? Try the next one by yourself. What would happen? Ignore this little mark over here. Right? So this should be 1 over 32 to the 2 over 5. But 32 to the 2 over 5, we already did that. This is 1 over fifth root of 32, the whole thing squared, which is 1 over 2 squared, which is 1 over 4. Okay. Keep going. Here, what about this one? This one just becomes the fifth root of x. That's it. You could say x to the 1, but notice that x to the 1 is the same as x. What about this one here? Try it on your own, right? This should be the fourth root of x to the 7. Okay. Next one. Oh, this looks like a good question. Take your time. Please try this one on your own, okay? Try. What will this one be? Well, this is 1 over 16 to the 7 over 4. You see how I'm taking my time? Then, okay, this is 1 over the fourth root of 16 to the whole thing to the 7th power. Now, what is the fourth root of 16? This should be 2. Because what number times itself 4 times gives me 16? It's 2. So then this is 1 to the 2 to the 7th. And what is 2 to the 7th? What is 2 times 2 times 2 times 2 times 2 times 2? This is 3, 6, 2. This is 2 times 2, 4, 8, 16, 32, 64, 128. So this is 1 over 128. Okay, very nice. Let's continue. Now notice that, what did we do for these questions over here? We went from fractional exponent to radical form. What do you think will happen for the next page? radical form to exponential form. Ay, mister. Okay, so try and do that with this one. Take your time. What would it be? This should be x. Notice that whatever is on that outside here will be part of the denominator. And this is 5. Take your time and try and go through the rest, right? This is one of them. 2, 3, 4, 5, 6, 7. Okay. These aren't too bad. This should be x to the 7 over 4, x to the 5 over 4, x to the 7 over 4, x to the 2 over 5. Oh, whoops, sorry, I messed up this one. This should be x to the 4 over 7. Sorry. Right. Oh my god, am I messing these up? I am, sorry. This is x to the... No. Wait, yeah. 4 over 5. I'm sorry. I'm making mistakes. My bad. This is x to the 4 over 5. My bad. Yeah, whatever's on the outside goes in the denominator. My bad. So then this becomes x to the 1 over 5. And then this becomes x to the... 6 over 6. Which is the same as x to the 1, which is just x. Okay. Very, very nice review. Now, the next question is, how do we take derivatives of these types of expressions? And that'll be for the next video. I'll see you there.